So today's lesson, we're going to continue on with equations, and I already did this kind of intro sometime in the back. So for those of you that you forgot, here it goes again. I remember I introduced equations using scales. Remember that? Yes? Yeah. So I said the concept of equations comes from the idea of scales. Scales need to stay balanced. So if I was to place some weight on this side, let's say 8 pounds, this side will go down. Is that correct? In order to balance it, that means if I add 8 pounds to this side, what do I need to add on this side? 8 pounds, and that's what's going to balance it up. Remember that?
Yes.
Okay. So I remember when I introduced that, I said, imagine that there's
A bag of frijoles.
No.
No?
No, I said there's a table. The table is right here. Your scale is on the table, right? And then the bar of the scale is up here. And I said that's where we get the idea of, if I move this around, what does that look like?
3.
An equal sign, right? Yes. So therefore, that's where we get that from. So with that said, our objective for today: I can solve and graph one variable equations. Read it together. 1, 2, 3. I can solve and graph one variable equations. Read it again. 1, 2, 3. All right. Copy that, please. And then let's get a fair model for one variable equations. One variable equations. Mathematical statements where two expressions are equal to each other and contain one unknown variable. Examples: x plus 2 equals 25, 2a equals 14, negative 3 equals m over 4, 12 equals 4y minus 8, negative 3 equals m over 4 minus 6. Copy those, please. All right, here we go. Pens down, eyes up here, just to double check. And like I said, this is a review. We've already seen this before. It says, mathematical statements where two expressions are equal to each other and contain one unknown variable. So, is this an expression? Yes. This is an expression? Yes. Are they equal to each other? Yes. Expression, equal to each other. Expression, equal to each other. Same here, same here. Only one variable? Yes. One variable? Yes. One variable? Yes. Yes, and yes. Are we there? Let me show you another example. Look at these. Look at this one. Look at this one. Look at this one. And look at this one. As you copy those, think about why these are not one variable equations. As you copy those, think about why those are not one variable equations. Just think about it. Don't say it out loud, please. Keep it to yourself. Go. Let's write our critical attributes. You said on these, this one was an expression. An inequality has an exponent of 2. This one has 2 variables. So the most important thing to remember that it has equal signs and one unknown variable. Copy that, please. Okay, now that we know what one variable equations are, let's copy the steps. Let's see, before I turn to that, who remembers the steps to solving one variable equations? 4 steps. Tell your neighbor the steps. Let's see. I gave you guys 4 key words. Remember, the first one was simplify, isolate, plot, check. Copy these, please. Simplify each side of the equation, isolate the variable, plot your solution, check your solution. Copy that, please. Once again, so that you remember the steps, circle simplify, circle isolate, plot, and check. Simplify, isolate, plot, check. Simplify, isolate, plot, check. simplify, isolate, plot, check. Okay? So here we go. Example number 1. Copy this down, please. Example number 1, write solve. I'm going to zoom in really quick. And notice this one is a one-step equation. Today we're going to be looking at two-step equations. This is a one-step, but I want us to get started together and walking through the steps. Here we go. Step 1. So, step 1 says simplify. Pay attention, please. Here we go. Can we simplify the left side anymore? No. The right side anymore? No. So simplify, isolate. Step 2 means isolate. We mean that we need to leave the variable by itself. So what do I need to do here to leave the variable by itself? Yeah.
Move it. You need to move it down.
Close, Isaac. Subtract the opposite or use inverse operation. So we subtract 2. Therefore, x equals 23, Michael Jordan. Copy that, please. No. Be nice. So, simplify, isolate. Did we do that? Yes. Plot. Let's plot our solution. Get your number line. Draw your number line down here. 0. Then you're going to do 1, and then dot, dot, dot. 23, and you plot your point. So simplify, isolate, plot, and our last step is to check. Write check right next to it. We're going to write this equation again, x plus 2 equals 25. But instead of x, what number goes there? 23, Michael Jordan. Bring down everything else. This is 25 equals 25. Is that true? Yes, that is correct. Is it coming back already? Yeah, right? Fairly simple. Now we're going to move on to two-step equations. We're done with this easy stuff. Here we go. Let's move on. Copy this one. Example 2. Example 2. And it's 3x plus 2 equals 25. 3x plus 2 equals 25. Let me zoom in on this one. 3x plus 2 equals 25. Let's do this one together. Draw your line down the equal sign. And first, on these, pay attention really quick. Pens down, eyes up here. On one-step equations, it was very simple to identify which operation was happening to the variable. But here, we have two different operations. Here, the first operation here, which is in between 3 and x, is multiplication. Look up, please. Multiplication is happening right there. But there's also addition. So equations are using the order of operations, but backwards. We're moving on the opposite direction. So whenever you have an equation and there's two operations happening, start with the last operation of the order of operations. What was the last operations? Addition and subtraction. So where's addition and subtraction? Right here. So what is the inverse of adding 2? Subtract 2. Subtract 2. Do that with me, please. Copy that. So I bring down the 3x equals 23, Michael Jordan. Be nice. Next, am I done? Leaving x by itself? No. Now we go with multiplication and division. So here's multiplication of 3. What is the inverse of multiplying times 3? Divide by 3. Divide by 3. X equals, let's see, I'm going to do the division here. 23 divided by 3. 3 fits in here how many times? 7. 21. Subtract, that's 2. You want to use decimals or just mixed numbers? Okay, like that. So it's a 7, and my fraction is 2/3. Yeah, you can leave it like that if it's simplified to lowest terms. So, simplify, yes. Isolate, yes. Plot. Let's plot our solution, please. Get your number line going, please, underneath. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8. So, 7 and 2/3 is in between the 7 and 8. Is that correct? 7 and 2/3? So it's right here. Plot your point about right there. So let's see. Simplify, isolate, plot. What is our last step? Check. So you're going to write check. We write the equation again. 3x plus 2 equals 25. But instead of x, I'm going to write, what am I going to write? 7 and 2/3. 7 and 2/3. Write it in parentheses. Bring down the 3. The plus 2 equals 25. All right. So, can we multiply this mixed number with this whole number? No, we need to make this first into a fraction. How can we make this into a fraction, everyone? Multiply 7 times 3 and add the 2. So what is 3 times 7? 21 plus 2? 23 over 3 times 3 plus 2 equals 25. We have, this became 23 over 3, so now we're going to multiply. So to multiply, let's make this 3 into a fraction. Is that correct? How can we make it into a fraction? Over 1. So this becomes 3 times 23, that's 69, divided by 3 plus 2 equals 25. What is 69 divided by 3? 23 plus 2 equals 25. Is 25 equals to 25? Yes. Copy that, please. Okay. So, any questions with the process? No? Okay, let's move on. Copy this next one, please. 3 more are going to appear. Let's start with this one. 12 equals 4y minus 8. This is still part of example 2. If you want to label it example 2b, that's fine. 12 equals 4y minus 8. See if you can do this one by yourself. Go. Okay, here goes the process. Line down the equal sign. Focus, please. Guys, look up, please. I'm going to go over this again. Identify the side that the variable is at, so over here. What operations do you see? Multiplication and subtraction. So where do I start? With subtraction. So what is the inverse? Add 8, add 8. We're left with 20 equals 4y. What is the inverse of multiplication? Division. Bless you. 5 equals y. Hands if you got that? That is correct. Draw your number line. Plot your point. 0, 1, 2, 3, 4, 5. There it is. And the check. 12 equals 4y minus 8. But instead of y, I'm going to substitute what? 5. So this becomes 12 equals 4 times 5 minus 8. 4 times 5 is 20 minus 8. What is 20 minus 8? 12. And that is correct. Hands if you got all those parts by yourself. Good. Okay, let's move on. Copy this next one. Here it is. Look up. It's still part of example 2. Negative 5x plus 12 equals 37. Focus, please. Negative 5x plus 12 equals 37. Do that one by yourself. Go. Okay, here we go. Here goes the process for those of you that are already finished to check your work. Line down the equal sign. Identify which side is the variable on the left side. What operations do we have? Multiplication and addition. So where do I start? With addition. What is the inverse? Subtract 12. Subtract 12. We're left with negative 5x equals 25. What's the negative 5 doing? It's multiplying, so we need to divide by negative 5. Divide by negative 5. X equals negative 5. Hands if you got that by yourself. Okay, good. Here goes my graph. 0, 1, 2, 3, 4, 5. Plot your point, and then our check. Negative 5x plus 12 equals 37. But instead of x, I'm going to substitute negative 5. Bring everything else down. This is 25 plus 12 equals 37. Is that true? Yeah, 37 equals 37. How we doing? Show me with your fingers from 1 being the lowest, 5 being the highest, how you feel with these. Got some 5s, some 4s. 5 4s, 5 4s. Some 3s and a halves. Okay. Let's do another one. Copy this one. Copy this. 28 equals y minus 15. 28 equals y minus 15. It's still example 2, and this one is an actual one-step equation, if you notice. Okay? It shouldn't take you long. Go. Okay, hands if you got 43 equals y. That is correct. So, we're good with these, right? Okay, let's move on. Copy these two, please. 8 minus a equals 14. And then leave like some space, and then we got negative 3 equals m over 4 minus 6. Don't do anything. I'm going to walk you through this one because it has a little curveball, and I just want to make sure that you identify it. Okay? Copy them first. Go. Okay, I'm going to zoom in just so that we can see what we're looking at here. Okay. Pens, pencils down. Look up, please. Lining utensils down. Look up to the screen. Okay, here it goes. First, line down the equal sign. And then, where's the variable at? On the left side. So I want to see what operations I have here. First operation that I see, it's a negative, which means a subtraction, but this is a curveball. There's no number in front of the A, but there's an invisible number there. What is that number? 1. So if it's negative 1, what operation is happening here? It's a two-step. It's multiplication right here. Everybody see that? That's a little curveball that I need you guys to pay attention to these. So if this is multiplication, what invisible sign is here?
Negative.
Invisible. Addition. So therefore this is a plus. So where do I start? With a plus. So how do we get rid of that 8? Subtract 8. Subtract 8. So then these cancel. We bring down negative 1a equals 6. Copy that. Did everybody see the little curveball? Yeah, right? Okay, so if there's multiplication here, what's my last step? Division. So we're going to divide by negative 1. Divide by negative 1. The answer, a equals negative 6. Everybody got it? Okay. So we're not going to graph or check on this one. I want to give you another one so you can try by yourself. Here we go. Example 3Q. Copy this one, please. Let's label this negative 5 minus x equals 15. Go. See if you can do that one by yourself. Here goes the process for those of you that got something different. Focus, line down the equal sign, identify the operations. There's multiplication here, and there's subtraction here. I'm going to start here. What is the inverse of subtraction? Addition. Add 5, add 5. We're left with negative 1x equals 20. The negative 1 is multiplying, so I'm going to divide by negative 1. Therefore, x equals negative 20. Pretty good? All right. And the last one, copy this one, please. Negative 3 equals m over 4 minus 6. Let's do this one together. Line down the equal sign. Where's the variable at? On the right side. Let's identify the operations. What operation's happening here? It's a fraction, which means what operation? Division and subtraction. So where are we going to start? With subtraction. So therefore we add 6, add 6. Yeah, inverse of subtraction is addition, right? We're left with 3 equals m divided by 4. So what is the inverse of dividing? Multiply. What'd you get, every day? Who got 12 equals m? That is correct. Pretty good? Everybody see that? Alright, so now in tonight's home play, you're going to have some that you need to write your equation. So watch, let me show you that. Give me a second. Let me go to that. Example 5, copy this. It says, solve the equation. 30 less than 4 times a number is equal to 14. 30 less than 4 times a number is equal to 14. 30 less than 4 times a number is equal to 14. Now, who remembers when we did translating expressions? Remember that? When we used to translate from words to numbers? Yeah, this is very similar. So here we go. Let's do this one together. Whenever you see less than, so for example 30 less than, that goes after the number. That goes written after the number. So let's start here. How can we write 4 times a number? 4x. That is correct. So now, we already got this. So therefore, if this goes after that, how can we write less than 30? Subtract by 30. Are we there so far? What does the word is stand for? Equal. Sometimes it's going to say is, or sometimes like here it says equal. But if it doesn't say equal, just remember that the word is stands for equal. And 14. Do you know how to solve that? Solve it, please. Go. Let's see. Answer. X equals 11. Hands if you got that. Okay, hopefully for tonight is on pages 188 to 189, numbers 1 through 11. Have a good one. See you guys tomorrow. Mr. Q.